This is the greatest moment of my life. I have bought something that I did not think I would ever be able to buy. In fact, I only have vague memories of seeing this technology before. And I am super excited. I haven't opened the box yet because I wanted to be able to film my reaction when I was opening the box. I know that is so YouTube-ish of me, but it's really, really cool. So what is inside here, and I'm gonna go through some of the history of this during this video, is a 10Broad36 transceiver, otherwise known as an ether modem, made by a company called ChipCom. So let me open it and see what we got. So this, so for those of you who don't memorize ancient Ethernet technologies, this was a technology that was used in the mid-1980s, the late 1980s, probably still in place in a couple places, maybe as late as the 90s. And it was a way of transmitting Ethernet over broadband. And when I say broadband, this is my definition. I think most definitions that are traditional broadband is frequency division multiplexing. So it used multiple frequencies over the same piece of coaxial cable to transmit in different directions and to different stations. I don't actually know the standard really well because I've never actually had to use it. But this is very different than every other Ethernet standard, which is all baseband, meaning that it is simply zeros and ones going across the entire frequency range. Okay, so let's see what we got. Nice packaging, good job. Person that I bought it from. Ooh, stuff a rattling inside. That's never a good sign. Good thing I don't want to actually ever plug it in. Okay. So this is a ChipCom Ether Modem 4. I've read online that there were Ether Modem 3s. This is the first 10Broad36 piece of equipment I have seen advertised. I got it off of eBay. Pretty much since I've been looking. I was very fortunate that a friend of mine who's now retired, who's a networking god, told me to look for ChipCom products. I had been exclusively looking for Ungerman Bass, which I know also made 10Broad36 equipment. So if we go into the back of this, we see it has two AUI ports, which are the DB15 ports. And it's also got this one, which is an RF port, which goes into 75 ohm coax, which is the same coax as is used in cable TV. So you could, if this were running, you could set it up such that you would run cable TV and Ethernet over the same wire, which is actually pretty cool. So 10Broad36, probably one of the most rare, at least one of the rarer Ethernet standards. For me, it's always been kind of a curiosity, because when I was first learning the different Ethernet standards, 10BASE5, 10BASE2, 10BASE-T, etc., there was this one that stuck out, and it didn't have the word base in the middle. So base means baseband, which very simply translated means that it takes the entire frequency space that's used by that particular transmission method, and it sends bits however they're encoded over that frequency space. Now that has gotten a lot more complicated recently, and one could possibly argue that they should evaluate the middle part of that name, but base has been used so many times that that's kind of where the IEEE is right now. But this one was 10Broad36, and it was called broad because it was the electrical engineering definition of broadband, which means that it used frequency division multiplexing, which meant that it used it did different things on the cables at different frequencies, and you could have multiple data streams going across this piece of coaxial cable, which is not unlike what you may have seen associated with cable TV or cable modems. And it would divide up the frequency space available on that coaxial cable and transmit different signals potentially in different directions. So I believe, but I'm not certain, I believe that I saw this working on undergraduate college campus in the late 80s, but I never actually physically interacted with the technology. So this is just a cover sheet from the IEEE standard, and it is one of the things that's relevant is the approval date by the IEEE Standards Board was September of 1985. So this is after 10-base-5 was available, which I believe was in 83 sometime, but before many of the other standards became available. And in fact, this came out just a few months after the 10-base-2 standard was approved, which I've already gone over in another video, which is the ThinNet standard. ThinNet used a relatively thin coaxial cable, but it was not the same cable as those used by cable television. Now, 10Broad36 actually did use 75 ohm coaxial cable, which is what was used by cable television. In fact, it was specifically designed so that it could coexist with, at least, I'm not sure about Europe, but with NTSC, coexisting with the NTSC broadcast frequency coded television signals on the same cable. So what was the motivation for this? So the motivation for having this standard was a lot of organizations had already been installing a lot of coaxial cable to support their cable TV plant. And since it was in a lot of places, the thought was, hey, we could save a lot. We could save organizations a lot of money by not requiring them to install new cabling. And you'll see this over and over again through the history of Ethernet. There's been these kind of retro standards. I don't call them retro standards. They were standards that were made explicitly to support existing cable plants. Interestingly, most of them didn't really work out long term. And maybe that was their goal. Their goal was to be there long enough for people to upgrade their cable plant. Because cable plant is expensive, right? You have to sometimes knock down walls and have people crawling in ceilings and all sorts of things like that. It's very disruptive when you have to rip out an entire cable plant and put a new one in. The other interesting thing about 10Broad36, other than being just kind of strange and being the only broadband standard, is that it used that last number, 36. It had the ability of going 3,600 meters. So remember, 10-base-5 can go up to 500 meters. 10Broad36 can go up to 3,600 meters. And that made this the choice for any type of long-distance Ethernet run. And before this came out, there really weren't any options. So, like I said, this was standardized in 1985, and it started to die around 1987. And I would say it was becoming increasingly washed up towards the end of the 80s, early 90s. And this is what killed it. FOIRL, which was the first Ethernet fiber optic standard. And its main use case was for having long distance Ethernet connections. And because of the complexity of messing with the coax and everything, it wasn't a great technology for doing that. Fiber optics, the introduction of fiber optics to Ethernet made it so much easier. And it seems like the market quickly shifted to everybody using fiber and being willing to install that new cable plant that we were trying to help them avoid. My uneducated opinion is that the fiber optic standards killed 10Broad36. So there just was never a lot of it around. And interestingly, we're still at this time where a lot of the IBM shops are using Token Ring. They're not using Ethernet. In fact, a lot of the more corporate environments are all on Token Ring. So the only places, or at least most of the places using Ethernet at that point, mostly based on my own recollection, were very academic research organizations, places that were kind of Unix focused, and not really like big central mainframe focused. So that's where it got used. And by the time the internet started to really fall into the public consciousness, which was around 1993, is when everything changed. 10Broad36 was long gone. Used 10Broad36 because it wasn't widespread, and the used market for equipment is close to zero. It took me over a year of searching and learning to find something for sale. So definitely universities were using it. In fact, there's a lot of stuff out there about in trade publications. And when I talk to some of my friends who have been working in university IT groups forever, they recall using 10Broad36, and they thought I had a very strange interest in it. And why would I care about something that old and that potentially useless at this point? But there's a comment in Network World about that made its way into Wikipedia, that people at Boston University were having trouble with this technology because it was just difficult to work with. I suspect that has something to do with just the variability of cable infrastructures. I don't think that cable TV infrastructure, at least at the time, was installed with a lot of tolerances. There are also non-university research organizations using it, and it seems like, just based on where I've been able to find used equipment, that there were some large forward-looking companies that were buying it. The equipment supply has seemingly dried up. Like I said, in a year of looking and calling old computer equipment recyclers, looking even in museums, I have found exactly one box for sale. Now, that box has a fairly big serial number on it, so I'm guessing there was a lot of it out there at one point. But there's certainly not a lot out there now. So I do consider it to be something of a trophy at this point. All right, well, that's it. I don't have any more equipment, so I can't make my 10Broad36 box talk to anything else. And in fact, so far I haven't been brave enough to actually plug it in, because I don't know what will happen if I assert power to some of these capacitors. I am fearful that there will be some smokiness. So for now, it's going to sit on my shelf, and like I said, it'll be one of my more interesting trophies. All right, well, thank you for watching this video, and I hope you find this stuff interesting. Subscribe if you do. Thanks a lot.